Welcome back to the World Model Podcast. In today's episode, we're going to be discussing the cognitive architecture, how the human brain implements a world model. We have spent this season deconstructing the artificial architectures of world models, but today we turn to the original, the prototype, the human brain. For 200,000 years, it has been running the most successful world model software on the planet. By understanding how biology solves this problem, we can better understand the path for our machines. This is not just a metaphor, we are finding that the brain structure eerily prefigures the design of modern AI. Let's start with the hippocampus. Neuroscientists like Karl Friston and Eleanor Maguire have shown that this seahorse-shaped region acts as a biological latent space generator. It takes the multimodal sensory input from the cortex, sight, sound, touch, and it creates a compressed, abstract cognitive map of our environment. This isn't a picture, it's a relational model. It encodes the spatial relationships between landmarks, but also the relationships between concepts, events, and people. It is our brain's representation model, constructing our fundamental perception of the now. Then we have the prefrontal cortex, particularly the dorsolateral prefrontal cortex. This region is crucial for planning and simulating future outcomes. Think of it as the brain's transition model. It takes the current cognitive map from the hippocampus and other regions and runs what-if scenarios. If I take this job, what might my life look like in 5 years? It doesn't have the perfect fidelity, but it allows us to mentally try out actions before we take them, to foresee consequences. This is the neural basis of imagination. Crucially, these systems are trained by a global reward prediction error signal, mediated by neurotransmitters like dopamine. When the world violates our brain's predictions, we experience surprise, and the dopamine signal acts as a learning signal to update our internal model. This is the brain's version of a gradient descent. We are constantly refining our world model to minimize the error between what we predict and what we experience. This creates a stunning parallel to the AI architectures we've discussed. The hippocampus is the VAE, creating the latent state. The prefrontal cortex is the RNN or transformer, performing the temporal prediction. The dopaminergic system is a reward prediction error that drives learning. It appears that evolution, through blind trial and error, converged on an architecture for intelligence that is fundamentally about building and refining an internal simulation of the world. This framework, known as the predictive processing or active inference theory of the brain, is revolutionizing neuroscience. It suggests that the perception is not a passive intake of data, but an active process of guessing. The brain is constantly generating top-down predictions about what it will sense next, and perception is the process of reconciling those predictions with bottom-up sensory input. My controversial take is that we are not building artificial intelligence. We are reverse engineering natural intelligence. The breakthroughs in AI world models are providing us with a new lens to understand our own minds. The latent space is not just a clever machine learning trick. It may be the fundamental currency of thought. The architectures of Dreamer and GPT are not just engineering solutions, they are mathematical glimpses into the logic of cognition itself. By studying the brain, we get clues for better AI. By building AI, we get testable theories for the brain. This virtuous cycle is perhaps the most exciting development in the history of both fields. If our own cognition is a world model, and we are building external ones, a profound question arises about the data that feeds them. Our next episode tackles the coming paradigm shift in how we feed these hungry models. This has been the World Model Podcast. We connect silicon to synapse. Subscribe now.